All right, everybody, here we go. Video 2, we're going to look at some examples. If you have not watched video 1, go back and do so, otherwise this won't make sense. Notice we have two shapes, blue and a red pentagon, and we know that they're similar because of this statement down here. That statement says LMNPQ, and then that little squiggly sign, ABCDE. That little squiggly sign means similar. Okay, it's another symbol that we have. So we have congruent, we have equal, and now we have similar. Okay. What similar tells us is that the shapes are the same shape, both pentagons, but their sides are held in a proportion, right? They have the same ratio. The ratio from one side in the blue to a matching side in the red will always be the same if we reduce that fraction. That's what scale factor means. We learned that in the last video. And so that's going to be the first thing that we're going to try and do, is we're going to try and find the scale factor. So I'm going to bounce over to the other slide because that's where I need to do my work. And so we're going to be bouncing back and forth. Notice in this slide, it asks us specifically to find the scale factor from LMNPQ to ABCDE, right? It's telling us the order, which I also kind of told you here on this slide by looking at the arrow, right? That arrow tells us the order that we're going as well, making us an enlargement, not a reduction. So if I want to find the scale factor, no problem. Scale factor I'm going to abbreviate as SF, but I should use the correct marker, SF. And a scale factor is simply just a ratio of two sides. The ratio is a fraction, and so we need to compare two sides, not any random two sides, but two matching sides. How do I know what sides match, right? The orientation could go in many different ways. So to figure out the sides that are matching, all I need to do is compare based on the statement that's down here that says similar. So let me get rid of the highlight and the word similar. And poof, it's gone. So based on this statement, LM and AB must be in the same proportion because they are the first two letters in each. Likewise, PQ and DE would have to be in the same ratio. NP and CD should be the same ratio, the same proportion. LQ and AE should be in the same proportion. You pick any two sides, and their ratio, that fraction, that scale factor has to be the same. So it's very, very important that as we're trying to find the scale factor, that we use matching sides, right? If I choose, say, side CB, CB would match up with NM. Well, that's kind of pointless. I don't have either of those values, right? I need values that I have that match. Now, an easy mistake is to go, well, right here, I got 6 and I got 18. Let's use those two. But those two don't match. 6 is LM, 18 is DE. Clearly, we can see that they're not in the same position in that statement, so we can't compare those two. That would be incorrect. But we can compare LM, because those are the first two letters, and AB, because those are the first two letters as well. So that will allow us to set up the scale factor because we have both of those sides and those sides match. So heading back over to our work slide, we're going to find the scale factor. Now, when we set up that scale factor, we always want the second image to go on top, to be in the numerator of the fraction. So our second image is the ABCDE image, and so we're going to look at side AB, and we'll compare that from the original, side LM. Then we just go back to our shape, and we get those numbers. So side AB is 9, and side LM is 6, and so we simply set up AB is 9, and LM is 6, and then we reduce that. It's very important you reduce the scale factor, because the scale factor has to be the same for every single matching pair of sides. And if one is a 9 over 6, when we reduce this, divide them both by 3, we get a 3 over 2. Maybe another one is in the ratio of 33 to 22. That's the same as 3 over 2. And so if we reduce them, we'll always see 3 over 2 instead of all these other fractions that are the same as 3 over 2, right? So that's the first thing done. We found the scale factor. It's 3 to 2, going from the small pentagon to the bigger pentagon. Notice this value is bigger than 1. A value bigger than 1, as we mentioned in the last video, means that we have an enlargement. If this were less than 1, it would be a reduction. So if we were, instead of going from LMNPQ to ABCDE, if we reversed that order, then all that would happen is we would reverse this fraction or do the reciprocal, and that would be 2/3, right? And if we went from A, B, C, D, E to L, M, N, P, Q, it should be obvious that pentagon is getting smaller, and so a scale factor of 2/3 being less than 1 would also mean that same thing, right? So just kind of making sure that we always pay attention to order and things like that, because it's going to be real easy to give me an answer of 2/3 when the correct answer should be 3/2. Not that we're testing on this, but in the future, you're going to get back to school. You're going to be testing on these things at some point, and that's very important that you have that locked in. Okay? Cool? Cool. Our next task is to find the values of x, y, and z. So let's find x first. Why not? We'll go alphabetical. So, to find x, if we go back to our shape, I'm going to definitely need to use side CD, because side CD measures x. I need to find a matching side for CD, so if I go to my statement, I can see that NP and CD must match. So NP is that side, which is 14. Perfect. So I can use those two to set up a ratio. I just need to make sure that I'm setting up that ratio in the proper order. So, once again, we're going to use CD and NP. Let's go over to our work slide. Now, just like in the scale factor, I need to always use A, B, C, D, E in the numerator, and L, M, N, P, Q needs to go into the denominator. So finding x, again, got to use the right marker. There we go. Finding x, I'm going to put CD in the numerator, and in the denominator, I'm going to put NP. You always, always, always have to use the same shape in the numerator every single time you're doing this. Otherwise, things are not going to work out. And so I've got CD compared to NP, and now I can just jump back again, making sure I've got the right values. CD is x, and NP is 14. So I have x over 14. Now, that alone will not allow me to solve for x. But because I have the scale factor, I know that whatever x is, when this fraction's all done being reduced, it should reduce down to 3 over 2. So to solve for x, what I can simply do is take this ratio and make a proportion, two fractions equal to each other, set it equal to the scale factor. Every single ratio that we come up with, no matter what those letters are, as long as they're matching sides, always, always, always must reduce down to the scale factor, 3 over 2. Now, there's multiple ways that we could go about solving this. My recommendation, whenever we have two fractions, and only when you have two fractions that are specifically equal to each other. You can't do this when you're adding fractions or anything like that. But if two fractions are equal to each other, you may have learned this from the past, that you can do something called cross-multiplying. And so I can multiply x times 2 to get 2x, and that's going to equal the other product, 3 times 14, which is 42. Notice, I still have an equation. There's still an equal sign there. That's important. Not only do I still have an equation, but I have no more fractions. I've often seen students write 2x over 42 and then get stuck. Yeah, you're stuck because there's no more equal sign. You need an equal sign to solve things, right? So once I have that, 2x equals 42, then it's real easy to solve. Divide both sides by 2, and we just found x. X must be equal to 21. I'm going to come back over to my picture, and I will put 21 there for our shape. Once I've got that process down, the rest of it is very, very easy. The rest of it's going to work exactly the same way. So the next thing we'll do is we're going to figure out what y is equal to. So I notice that y is PQ. That's got to match, according to my statement, DE. There's DE. DE is 18. And so I can jump over to my other slide, and I can set up that proportion just like I did for x. So once again, we're going to be using the two sides, PQ and DE, but we got to make sure we put them in the right spot. DE is the bigger one, so DE is going to go on top of my fraction. So to find y, we're going to set up our fraction of DE. Same shape, always on top. And on the bottom, matching to DE, was PQ. Jumping back to the shape, just to make sure I've got the right numbers, DE was 18 and PQ was y. And so this is going to equal 18 over y. Just like we did for x, that has to also reduce to the same scale factor of 3 over 2. I can do the same strategy that I used for x. I can cross multiply. 2 times 18 is 36. 3 times y is 3y. And then if I divide both sides by 3, y ends up equaling 12. And so I can jump back over to my shape, and I can put a 12 there where y is. Perfect. Now, the last thing that I need is I need to figure out what z is equal to. So let me get rid of the highlights. I'll put that 12 back there in a second. There we go. Y is equal to 12. Now we got to figure out z. So if I look at my shape, I can clearly see that side AE, and side LQ definitely match. And so those two must also be in the same proportion, in the same ratio, And so we'll set up a proportion to solve for that. So jumping back over to the other slide to find z. I left myself a nice amount of space, but I need the right marker to find z, because z is going to take a little more work. It's not too bad. It's the same process. It's just not as easy as just finding x or y, because x and y were just an x and just a y. So, as I said, for z, jumping back to the shape, we're going to use side AE and side LQ. So, setting up that ratio, AE compared to LQ. According to my picture, AE, we jump back, we can clearly see that AE is 7z minus 12, and PQ is 3z plus 2. So if we put that into the fraction, 7z minus 12 over 3z plus 2, that has to be equal to the scale factor. Everything is always equal to the scale factor when you're talking sides, not when you're talking angles. So 3z minus 12 over 7z minus 12 over 3z plus 2 must equal 3 over 2. And now I can employ the exact same strategy that I used for the others. I can cross multiply. So I'm going to multiply 2 times the 7z minus 12. 7z minus 12. And that's going to be equal to 3 times the 3z plus 2. Perfect. That's solvable, right? We know how to solve that. That's an integrated one solving issue. No big deal. We'll just distribute 14z minus 24. That's going to equal 9z plus 6. Almost said minus 6. Plus 6. And then we can solve it. I'm going to go through this quickly just to get this video done. Subtract 9z from both sides. We get 5z. Add 24 to both sides. We get 30. Divide by 5. And we figured out what z is. Z is equal to 6. Y was equal to 12. And x equal to 21. Our scale factor is 3 over 2. And we can plug in that. I could put z as 6 over here, but it doesn't make sense. But now we've got everything. The only thing that we would never be able to find, anything about side MN or CB, because I have no information at all about those sides. But otherwise, we've got all the information we need, and we've used the scale factor to get us there.